very warm good morning, my dear students. Hope so you all are fine and enjoying these digital classes nowadays. So dear students, before going to start today's topic, let me share some of the important instructions to you. Number one, first instruction is that now, as you know that with theory there is practical also, so practical is also very important. So now I'm going to share one practical today that is related to crystallization practical, although this is the same practical that you have done in +1 class also. So please, dear students, try to note down those practical, and it is my humble request that you just buy the practical notebook from the market. Any practical notebook that you bought last year also, it is available in the market, and try to complete the written part. Okay, I am going to share you which practical you need to do, then after that you have to complete those practical work. But right now you just do our practical number 1 and 2, that is related to crystallization practical, in which we are doing that to prepare the double crystal of potash alum, or there is one potash alum, second is mohr salt. Okay, so you need to prepare those double crystal. The preparation is same. The process is first making solution, second filtration, and then third is purification method. So by doing crystallization process, the practical which I am going to share you video, from there you can prepare and make the practical. Okay, the moment you will come to school, you will perform the same practical in lab. Okay, so hope so you got my point. Now let's start today's topic, that is F block element, where lengthenide series yesterday we did. Today we are going to do actinide series, and with this the chapter will be finished, and you all have to revise the chapter, because Monday I'm going to give you a cycle assignment so that you will see where you are facing problem, and you can ask wherever any doubt is there. Okay, so stay tuned. Today's topic, let's do. A very warm good morning, my dear students. Welcome to this district chemistry class. As we have started yesterday our F block elements, which is the second series of this unit 8, which we are doing. In unit 8, basically the chapter name is D and F block elements, in which D block elements already we have done. Now we are doing F block elements. In F block elements also, the lengthenum and actinide series are there. Lengthenum and actinide series are there, which is consisting of 14 elements in each series, so total 28 elements. So these 14 elements are known as inner transition elements, whereas the inner transition element starts from third group and in front of sixth period in the periodic table. So these are very important group of the periodic table, because most of these these elements are rare earth metal and somewhere the radioactive also. So element in which the last electron feel up in F orbital are known as F block elements, whereas these elements are also known as inner transition elements. They are also form resembling one another more closely than to the member of ordinary elements in any series, because they possess only one stable oxidation state, and their chemistry provide an opportunity to study the effect of small changes in size and nuclear charge along a series otherwise similar elements. So two important properties are there, that is Lengthenide contraction and Actinide contraction, which we are going to study particularly in this group. So let's start the lengthenide F block elements, what we studied. So the element in which the additional electron enter in n-2f. What is n-2 now? N is principal quantum number, which we can represent with the period also. Suppose any element, any series which in front of 6, then for F block that's 6 minus 2, it means that n is 6, so it will become basically 4f. Okay, so those elements which is present in front of 6th period, their configuration will be 4f. Those who will be in front of 7, their configuration will be 5f. Okay, this is the meaning. General electronic configuration is n-2 f 0 to 14, n-1 d 0 to 1, ns2. Here yesterday I told you about that why d is not 1 to 10 here, why d is 0 to 1, because these F block elements present in the periodic table, especially in the first group of between first 0 and first group of D block elements. Okay, so next if we will see Then there is a general configuration, electronic configuration, that you know. Electronic configuration will say, so it is in series 47, 57, 58, 59, like this way up to 71. But the general thing that is need to be noticed, that is this configuration. Okay, where is exceptional? F2 1 is there, F2 is not there, F3 is there, F4 is there, 5 is there, 6 is there, 7 is there, F8 is not there. So this thing need to be note down and you need to be follow this. Next is atomic and ionic size. That is very important property, where lengthenide contraction we studied. What is contraction? Contraction is with the increase in atomic number, the atomic size is decreasing, or somewhere because of that atomic size decreasing, down the group atomic size is increasing. So it means that in case of second group, or I can say the F2, F3, these hopnium and especially hopnium, cerium, these are almost similar in size, almost same type of atomic size, atomic radii. That is called atomic lengthenide contraction. Okay, so as the atomic number increase, each successive element contain one more electron in 4f orbital and one proton in the nucleus. Because of this extra proton in the nucleus, the 4f orbital the 4f orbital electron are ineffective in screening the other electron from the nucleus, which causing imparting shielding. There is shielding effect. As a result, there is a gradual increase in the nucleus attraction for the other electron also. Consequently, what is happening in the end? The gradual decrease in size is occurring with the increase in atomic number. That is called lengthenide contraction. The same thing is there in actinide also, which is called actinide contraction. So that we will study in next group. So what are the major consequences of lengthenide contraction? There is close resembling between 4D and 5D transition elements. There is ionization energy of 5D transition series, which is higher than the 3D and 4D transition series. There is difficulty in separation of lengthenide. Okay, because of that the lengthenide's contraction is there. Now if we will see, so next is ionization enthalpy. That is one of the property of lengthenide contraction. In ionization properly, it is fairly low ionization enthalpy. First ionization enthalpy is around 600 kilojoule mole inverse, where second is 1200 kilojoule mole inverse, which is comparatively with those of the calcium. So due to low ionization enthalpy, lengthenide have high electropositive character, metallic character. So colored ion, it is also the property of D block elements. So similar properties there, F block elements in lengthenide. Many of the lengthenide ions are colored. Reason? Because both solid add well in solution. Reason is like most of the D elements were colored due to DD transition. So here most of the F block elements are colored due to FF transition, or transition means partially filled F block elements. Okay, whereas 14 electrons are there, so it means that 14 orbitals, 7 orbitals can be incomplete. So plus 7 up to 7, it is oxidation is there. Absorption band are narrow, probably because of the exciting within F level. Lanthanum 3 positive and lutetium 3 positive ion do not show any color due to vacant and fully filled F orbital. So this was the third property. Now next property is magnetic properties. It is also one of the important property. Here I just want to tell you, dear students, all those properties which we have studied in d orbitals, similar properties are there in f orbital also, because f orbital is present in between the d orbital and it poses maximum of the property of d block in f block also. So the lengthenide ions other than f0 type, suppose lengthenide 3 positive is f0 type, cerium 3 positive is f0 type, and f15 type, which is fully filled, this is the yttrium and lutetium 3 positive, are all paramagnetic in nature. The paramagnetism rise to the maximum in neodymium. Okay, lengthenide have very high magnetic susceptibility due to their large number of unpaired electrons. So there is a very simple relation between magnetic properties and unpaired electron. Most of the unpaired electron, they are paramagnetic in nature. Those most of the I'm telling the reason. Most of the magnetic, I can say most of the element which is paramagnetic paramagnetic mean incomplete field. Unpaired they are paramagnetic they are colored. So this is the basic reason. Mean all those elements which is colored, they are paramagnetic in nature. Paramagnetic means singly filled electron or half filled electron. Okay. Oxidation state, if I'll say, the most probable oxidation state is +3. +3 is the most probable oxidation state, whereas +3 oxidation state of lengthenide and GD is gadolinium and lutetium are specially stable, empty half filled and completely F filled. Cerium and if I'll say cerium and terbium, these show positive +4 oxidation state, whereas rest occasionally +2 and +4 ion in solution also. This irregular rising mainly form the extra stability of empty, half filled and filled f orbital. So this was the oxidation state. Now in this way, the most stable oxidation state for lengthenide is +3. Hence the ion in +2 oxidation state tends to change +3 state by loss of electron, whether from 4f or from 4s. So there is one question, why Sm plus 2 positive, Eu 2 positive and white B 2 positive ion is solution. These solutions are good reducing agent, but an aqueous solution of cerium 4 positive is a good oxidizing agent. Reason? So there is a reason is chemical. We will find in properties, because silvery, general property of lengthenide is what? It is silvery white soft metals tarnish in air rapidly, hardness increase with increased atomic number, whereas samarium being steel hard, good conductor of heat and electricity. Promethium is radioactive. If we will talk about chemical properties, so basic chemical properties are, with oxygen it is form oxides, with hydrogen it form hydrides, with sulfur it form sulfide, very simple. Water it is form hydroxide, with metal it produce hydrogen gas. And so generally in chemical properties, metal combined with hydrogen when gently heated in the gas. The carbide are formed when the metal are heated with carbon. They liberate hydrogen from dilute acid and burn in halogen to form halides. They form oxides and hydroxide, basically alkaline earth metal oxide and hydroxide. Okay, so actinide is what now? Dear student, this is the today's topic basically, but I made the separate different presentation that from yesterday, in which the special physical properties of lengthenide was there. That's why I revise lengthenide again. So it is my request that you need to note down all those physical property which I told today, including lengthenide contraction also. Now actinide, the general configuration start from 5f, the in front of 7, total 14, but all elements are mostly radioactive in nature. So basically all isotopes are radioactives, with only thorium, uranium, or I can say which have long half-lives. Only thorium and uranium occur naturally. Both are more abundant in Earth's crust than the tin. So the other must be made by nuclear processes also. So we are talking about nowadays nuclear reactor, nuclear energy, that is somewhere radioactive. We are talking about radioactive elements. So the dominant oxidation state of actinide is like lengthenide, that is +3. Actinide also exhibit an oxidation state of +4. Some actinides such as uranium, neptunium and plutonium also exhibit in oxidation state +6. The actinides show actinide contraction like lengthenide contraction due to poor shielding effect of 5f electron, whereas in lengthenide 4f electron. Here in actinide there is 5f electron. Okay, so the contraction is same with increase in atomic number. The atomic size is decreasing. That is called lengthenide contraction. The actinide are radioactive. Actinides are radioactive in nature. This is most important characteristics that you need to keep. It is radioactive in nature. So next is actinide contraction. The size of atom, which is M3 positive ions, decrease regularly along the actinide series. The steady decrease in ionic and atomic radii with increase in atomic number is called actinide contraction. So sometimes simple definition is coming in 1 mark. What do you mean by actinide contraction? So you can write, okay, with increase in atomic number, the decrease in regular atomic size or ionic size is called actinide contraction. The contraction is greater from element to element in this series due to poor shielding effect of 5f electron. This is the cause. So if we will talk about electron configuration, so basically electron configuration is 5f. Okay, and if you will see by zoom, so you can, the atomic number is from 89 to 103, 89 to 103, and the configuration is basically from you can see actinide 6d1 7s2, it means that 5f0. Second thorium 5d2 7s2, then protactium is 5f2 6d1 7s2, uranium is 5f3, neptunium is 5f4, plutonium is 5f6, there is no 5f5, 5f7, then again 5f7, 5f8 is not there like a lengthenide, 5f10 is there, 11 is there, 12 is there, 13 is there, 14 two times. So this is need to be see very carefully and note down all these configuration. Sometime question is coming. If general configuration we will talk, the thorium is general configuration. So magnetic properties paramagnetic in nature, and simply by paramagnetic nature because most of the incomplete electrons are there. Magnetic properties are more complex than those of the lengthenide. Its melting and boiling point are higher than the lengthenide contraction because it do not follow regular gradation of melting point boiling point with increase the atomic number. Okay, so if next property we will tell, so ionization enthalpy, it has low ionization enthalpy, so electropositive is high. Color, generally colored because of again FF transition. Color depend on the number of 5f electrons. The ions containing 5f0 to 5f7 which are colored, especially uranium 3 positive which is red color, and neptunium 5f4 that is bluish in color. So note down this is very important general question. So dear students, if I say about the lengthenide and actinide, so very important question is coming, one that is similarity between lengthenide and actinide on the basis of its similarity and differences, and application of D block. So note down please. First application of lengthenide are, it is used as a catalyst in petroleum cracking. It is used as a catalyst in petroleum cracking. It is used in producing alloy. It is used in producing alloy. Third use is oxides of lanthanides. Oxides of lanthanides are used to produce red color on television screen. Fourth, actinides are used in nuclear reactor for producing the electricity, which is nowadays every country is going to make, and actinides are also used for the synthesis of transuranic elements. Okay, if we will talk about the differences, so basically on the basis of similarity, first similarity, both the actinide and lengthenide, these are posing +3 oxidation state. Both the lengthenide and actinide pose +3 oxidation state. Both are electropositive. So note down this similarity. Both are electropositive and have high reactivity. Both the lengthenide and actinide are contracting. Lengthenide and actinide contraction is there. Both show ion exchange behavior. Ion exchange behavior. And in both the series, in both series f orbital are being progressively filled. Okay, both the series are related to f block. So these are the general 5 similarities. Now if I will talk about the differences. First difference is on the basis of oxidation state. See, lengthenide they show mainly +3 oxidation state, whereas +2 and +4 is also existing. Whereas in f block there is +3 is main, but +4, +5, +6 is also there. Okay, +6, even +7 is also there. So this is the first difference on the basis of oxidation state. Then second difference, if I'll say on the basis of bonding energy, the binding energy in lengthenide is 4f are higher, whereas the 5f is lower. Okay, next is shielding effect. If I'll talk shielding effect, so f block lengthenide have poor shielding effect, whereas actinide have poorer mean more poorer than lengthenide. Okay, it is poorer than lengthenide. Next is on the basis of magnetic properties. F lengthenide is having paramagnetic nature. Their magnetic properties can be easily explained, whereas in actinide they are also having paramagnetic, but their magnetic property cannot be easily explained. Here easily explained, paramagnetic can easily explained. Here it is not possible to not easily explained. Okay, so I think you are able to heard me and you are able to understand that. Now on the basis of chemical property, lengthenide tendency to form complex is less, whereas in actinide tendency to form complex is more. Second property of chemical property is that radioactive except promethium, lengthenide are non-reactive. Except promethium, lengthenide series are non-radioactive, whereas on actinide series all are radioactive substance, all are radioactive. Okay, next is last difference. Lengthenide on the basis of basic character, lengthenide have less basic character, whereas actinide is more basic character. So these are the general differences, although I will share you the similarity and differences notes also in PDF, so from there you can note down. Okay, so this is all about the today's topic. That is, I told you, let's recapitulate. I told you about F block elements, in which we studied about lengthenide, basic property of lengthenide, and actinide series. Okay, so this was all about, dear students, today's topic. That is, we have done, suppose, the most important questions that is coming in during this D and F block chapter, that is related to structure type question, structure of potassium dichromate and potassium permanganate. But most of the question that is coming, suppose, from D block, if I'll say the question generally, why D block elements are forming catalytic, why D block elements form complex compound, why D block elements form colored compound, why D block elements are known as transition elements. So all these logical and reasoning question, there are a couple of few reasons. You need to search those reasons. After that you can solve those questions. From F block elements, if I will say generally, the questions that is coming that can come from lengthenide contraction and actinide contraction. Most important question is coming, that difference between lengthenide and actinide, or on the basis of similarity and on the basis of differences, just relate the lengthenide with actinide series. Then the question can come application of D block elements and F block elements. Then question coming from properties, basically oxidation state, as I told, atomic kinetic radii, and metallic properties, alloy formation. Okay, these are the some basic questions. So hope so you like the videos, you enjoyed the videos, and you understood all the topics. Okay, now it is my appeal that you all will prepare your own video after watching this video. So thank you, stay home, stay safe. And now it is very important, especially in district Kullu, as the cases are coming. As you know that yesterday 47 cases has recorded. It was record breaking, first time it happened in Kullu. So those students, those who are somewhere migrating from here to there, they need to take care. Although the effect of this coronavirus is very less now, it is not like that much I can so threatening, because the death rate is very less and people are recovering very fast. Within 5 to 6 days they are becoming from positive to negative. But still we need to take care, we need to stay ourselves healthy, we need to stay ourselves hygienic, and we need to take care all the precautionary measures by using mask, by using sanitizer. We can save our life as well as our family life. Okay, so I wish that very soon we will meet in school, as now government, these kind of news is coming, very soon school will be open. And dear student, we are thinking to take your test in the month of September also. So it is my request, just prepare yourself for the test. Okay, term 1 syllabus, all these chapters will come which we have done. So thank you very much once again, and thanks, have a nice day.